Hello everyone. So after seeing several videos on this spot welder, mini spot welder, I noticed that there are several problems with it, and the one I ordered recently was different than the one that's being reviewed, that was at least reviewed a few months ago. Basically, the faceplate remains the same, but if we check the insides, specifically, just don't mind this IC yet, I will remove it. Specifically the controller board, the top seems the same, but the bottom, as you can see, is rather different. Now, I don't have the prior version, but there are several videos on this, on the other model. This one, you see I removed the MCU here, which is of unknown manufacturer. I don't know what it is. It's certainly not standard Atmel or anything, because I can show you they have removed all markings from it, and so you can't really see. It's a 20-pin DIL. Power is pin 9 and ground is pin 7, I think. On this side there are a bunch of I/O lines and a couple here, so it's not really a standard IC. I don't know, I'll investigate it further. Anyhow, this is it. Why did I remove it? Well, because it's simply dead. It was working and then it just died. So, well, I will get to that later. The main part is what I think is that these two revisions are actually are probably made by two different manufacturers. Why do I say this? Well, basically, the first one has the controller board with the driver circuit, the FET driver circuit here that drives the gates. That is actually on board here. There's a diode, the layout is different, there's an array of resistors. The problem with that one is that the 10,000 microfarad capacitor, which is here, is not wired correctly, meaning that if the voltage of the battery drops, and it does, and it will, and it drops low enough, the driver circuitry will fail to drive the FETs correctly, and that will either overheat them or keep them on too long, or just blow them, which is what regularly happens on that version. There was a fix proposed by maker Fabio by adding a second cap on board through after the diode and to the negative side here. As you can see, it's actually a little bit different. These are the programming pins on the first revision. They go through, these ones don't. Anyhow, this one is labeled BK, if it focuses, BK11-1K. Now, this one has other problems, more than one. And unfortunately, yeah. First of all, yes, they did get around fixing the, let's say, under voltage problem, because the driver circuit is now on this board, and I will show you where. If you lift this cap, here it is. It's actually simpler in design than the one of the first board. There are 3 transistors here, 2 NPNs and 1 PNP. These two here are, let's say, with a base connected in common. One turns on and one turns off, and the opposite happens based on the driver, which is this transistor, which base is connected to pin 2, which is equivalent to pin, I call it pin 2 because I start from the bottom here, okay? Pin 2. This pin, you can see, goes through here. There's a via, comes out here, is connected to this resistor, goes around here, and then is connected to this pin here, which is, as you can see, pin 1 is here, it goes all the way around, it's pin 19. Okay, so this is the trigger circuit, okay? This just triggers. Now, as you can see, this resistor here is missing. I didn't remove it. This is a pull-up resistor. Unfortunately, with this pull-up resistor, the circuit doesn't work properly, and they removed it after, let's say, production. This is one of the problems. Now, what happens is the trigger circuit reaches this transistor. Okay, the problem is that this transistor has to be driven. It will conduct when it's 0.6 volts on the base at least. Now, if you flip this over, you will see, now I've already done this mod here, that the original version, when it comes, there is a little wire here, copper wire, connected to an SMD resistor, and which goes to pin 2, which is a trigger. Then there is this little other SMD resistor, which is connected to ground, and this is a 1K. So it's a 1K, 10K divider, okay? This is to ensure a certain voltages here when there is no driving circuit. Now, the problem with mine, and the problem I probably with others, is that this resistor, which is bodged on very badly, does not really make well contact. It didn't with mine. It would work sometimes, it didn't work. I didn't understand why. It was sometimes welding, sometimes not. It was really driving me crazy. So in the end, I blew a FET because this thing wasn't making proper contact, which, as you can see, I had removed them all and checked them all and then resoldered them. And after checking with a limited current power supply and driving the trigger circuit and everything, I could notice that the driving voltage here on the exit of this collector, this is a little transistor with this one, and here is the array of resistors. They're all a pull-up, pull-down, as you can see. Each couple of resistor is connected to one gate, okay? So this is done because these gates are not connected in parallel. If you connect them in parallel, there is a capacitance problem with FETs, and you have to take note of this. And so you drive them separately. These gates are separated, and they each have a 30 ohm resistor in series, and then there's I think it's a 10K. I have to check again. This is again a voltage divider, and the output here goes to, as you can see, connected to each of these resistor arrays here, and each output then goes to each single gate, and you can see on the back rather clearly 1, 2, 3, 4, 5. You see, these are the vias, and they go to each individual gates. So this is how this version of the board is driven. Here is the diode. This prevents the reverse discharge of this large capacitor going back down towards the drain, which is the battery, while you are spot welding. When there is a peak current and the voltage drops rather much. And if that voltage drops for too long, as I said, then this circuit will fail. Now, FETs should have at least 5 volts, 5 to 6 volts on their gates to be properly driven. I checked, actually it should be more. I checked with my scope, and with this circuit, when everything is working, it's rather 8.4 volts. It doesn't drop under that with the 99 milliseconds set on the microcontroller. So this part of the, let's say, circuit is working pretty well. I tried limiting the current and driving it with 99 milliseconds, and the voltage here was around 4 volts, and here it was still 8.6. So the driving circuit, let's say, regarding the voltage is fine. What is not fine is this work here, which they should have not done like this, especially with that bodge wire and this little SMD, which is 45 degrees out here. Of course, I removed it, but if you check on various pictures on the internet, you will find this little bodge. And this is one of the culprits, I think, of the problem, which at least I had. It was working, and the false contact, or rather this 10K resistor has to be connected properly, because otherwise the voltage here is not correct. and it can keep your FETs on or off, but rather on too long, and that's when they blow. Now, which is exactly what happened to me. So first thing, if you receive one of these boards, please remove that dodgy thing and just put a normal resistor. This is a quarter watt 10K resistor between this pin, okay, and the second pin here. That's what you have to do, and tie it down, put a little drop of hot glue or whatever. Just this thing has to be well done. This SMD resistor here is okay because it's not going anywhere, but this one, like, it was, you know, very dodgy. So in my case, at least, that was a problem. That's the first thing you should do, at least with this model. You don't need to do any other cap mod or anything. Just check that when you power this without the board, the FETs are off. Okay, so check that there is no voltage here when you're powering it with your battery, because when this is disconnected, the voltage, the FETs should not be excited. You should not see any voltage on this pin here on the, if you check here on the output of this transistor, which is driving this array, it should be low. So that's the first thing. If you find voltage here without anything connected, something is wrong. Do not use it. You will blow your FETs. Okay, this is a thing that you should check. What I must say also is I see, and this has been already talked about in many other videos, I see people using small lead acid batteries, 7 amps or whatever. Those are absolutely not correct. Do not even use alligator clips. You do not know how much current this thing needs. It's a few milliseconds, yes, but if you do not have them wired correctly with good screws and clips, or even better, something like this screwed onto your battery, okay? What I suggest is using maybe even a small battery, but it must be AGM, okay? Like a small motorcycle battery, it must be good. That can give you at least 130, 150 cold cranking amps, okay? If you don't have that, don't even use this. You will break it. You will short out the FETs. The transient is not fast enough. It's not going to work. And possibly screw both terminals on the same nut. You don't need to use this this soldering or this bridge here. This is just a simple bridge for easy connection, but it's a loss. You don't need this. Just connect both of the positive leads here, the spot welding one and the power supply, either here or here. Better here, so you have them the same length. Or you can connect them both here. Just connect them both together. Be sure they are clipped and screwed on well. The negative side also, just be sure they're screwed on well. One here, because of course the FETs are on always the negative sides and FETs. So another thing is be sure you have a charged battery. Okay, the voltage is not 12 volts, so it's a 3S. You can use a LiPos. The only thing with LiPos is that if this thing fails, and they're prone to fail, and you have your two electrodes which are stuck onto the weld, which can happen, usually don't, but it can, they will, let's see here, these will either destroy completely your contact, open it up, it will vaporize if your battery is powerful enough, which is better. If your battery is not powerful enough and they will stick, either you rip them off or your battery will tend to explode. So AGMs don't do that, okay? I don't suggest using LiPos, but okay, if you have a strong, powerful battery pack and it's charged, okay. I mean, it's just keep it in a safe, maybe surface, something that doesn't catch fire, because if the short is long enough, it can, just half a second is enough to compromise the battery, and it can, that's not good. AGMs, car batteries or small AGM batteries, they don't do that. If you can, they will melt your cable, the battery won't blow up. They can be abused. The only thing you need to do with AGMs is keep them charged.
They love, I mean, they don't hate high discharges. They can cope with them easily. That's why they're used in cars for starting engines, and that's what they're built for. And they're long and reliable. I use a small 12 ampere hour motorcycle battery from my motorbike. It's let's say used one, but it's perfectly fine. It will rip open anything, and as I've used it before. Oops. And so basically the problem with this is additionally that this MCU here died. Now, why did it do this? Well, okay, the pins on this side, they are not connected to anything, so don't even consider them. Now, the thing is that there is no real shielding, meaning that if even when this is closed, okay, you have this top cover luckily and the bottom cover, which protects your contacts here, which is fine, especially the trigger circuit. Oh, by the way, the pin in the middle, let's call this pin number 3, that's the sense. You see these two resistors and the diode, it's another voltage divider. It picks up the voltage from here, okay, from this side of the FET, which is closed. It's usually open. So when you touch these contacts together, it will sense voltage here. The voltage here will rise and will give the MCU the go to automatically spot weld. So that's the automatic setting. It depends on this little resistor array here, okay? I think it's another 10K, 1K. I'm not sure, maybe it's a 4.7. Anyhow, not a big deal. This is a diode because it prevents the reverse, of course, current. Anyhow, so it senses it, and after a second, it will beep and it will weld. That's in the automatic setting. In the manual setting, you just use this plug, and when you short it, it just welds. Okay, it doesn't wait a second. It welds immediately as soon as you contact it. So as I was saying, I had repaired this. It was working, and I don't know if maybe I touched one of these contacts or something. This thing just went blank and it died. And the MCU here is actually shorted out. It's the regulator on the board here. This is a 3.3 volt regulator. It's going into current limit because this gives 100 milliamps. If I power it separately, it will go to, I don't know, over 500 milliamps. So the thing is dead. Unfortunately, there is no code. Everything is like proprietary. It is possible, I believe, to probably use an Atmel or maybe an Arduino and replace this driver board or integrate it to drive this, because actually this is the most expensive part. Okay, these FETs are the most expensive part. So anyhow, I ordered another board. I told, on AliExpress, because I told them, hey, you can't sell this stuff like this because it's prone to fail. This stuff, if you drop it or during transport something is wrong, that little component does not make weld contact. It's a small resistance and it's just soldered on one end, probably not even well. And I just tried it with it looks soldered, and I went on with my tester, and based on what I touched, it would contact, it wouldn't, so I just removed it. And when I soldered on the 10K resistor like this, everything was working fine, as I said, until the MCU died. So I unsoldered it, and everything was fine. All the components here were okay, but yeah, that's dead. So my suggestion is, first fix is this. Secondly, be sure to use a fully charged battery. Do not use those gel acid batteries. They are not for this purpose. You need a low internal resistance battery, like a car battery. A small motorcycle battery is fine too. LiPos are, a 3S is fine, 5,000 milliamps upwards with 40C discharge, let's say 35, 40, if it's okay. The only thing with LiPos is, these are dodgy things. They can fail, and you have a little bomb close to your face. So I don't know, those packs, I also was RC, using RC airplanes and stuff, and I've seen a lot of people getting their hands burnt, and all these packs, like, they they become bulgy in just a couple of seconds. You can't set them out. If they start burning, you know, and you're outside, so that's a little bit safer. But when you're in your home and this happens and you can't remove the weld, you're gonna drop this stuff and this stuff is gonna catch fire. So I don't know, it's not the best. I would suggest using small motorcycle batteries, but they have to be AGM or just regular lead acid. Do not use gel. Gel batteries are not for this purpose. They will not deliver this current. You would need an enormous gel battery to do that. Anyhow, so these were my observations here. I will check if when I receive my other board, maybe in the next couple of weeks, I don't know, I'll do some checking and see if everything's okay. Yeah, you can use this also with four FETs. They are powerful enough. It will still work. Maybe not use it at a very high power setting. But as I said, basically the problem is on these boards, it's not really that the FETs aren't powerful enough. The FETs just have to be turned on and off precisely and very fast. That's the most important part. If you notice on this board and on the other board, when you trigger it, the display goes blank. It does that because it has to be a very precise timing. I checked it with my scope and it's very precise. This goes from 1 milliseconds to 99 milliseconds and it's dead on. So they did a good job on the timing. They blank it to not interfere with the timing. Basically, yeah, you could, like, for example, I don't know, do it in a separate loop or whatever. They just, when it does this, it waits and then goes back to the main loop, which is handling the display and your inputs. Another difference is that with this revision, when you turn it on, it does not memorize and remember your last setting. You turn it on, it immediately turns on, and it gives you 5 milliseconds. You start from there. With the first version, you turn on and it kind of, I see it's slower and it kind of like recalls your last welding setting. I prefer it to start from 5 milliseconds, which is the lowest. To weld normal 0.1 millimeter nickel strips, if you have a strong battery, I mean, I never went past 30 milliseconds. That's already getting way too much. 20 is fine. If you have a weaker battery, then you need to increase the time. Increasing the time will increase the strain on the FETs. But okay, I mean, they can handle it. But keep that in mind that with different battery packs, you need to adjust the settings. Always start with a low setting. Apart from that, as I said, I think these are actually maybe two different Chinese manufacturers, and one kind of like copied from the other, and they use kind of like a shared design. I don't know, or maybe they're the same and they did a different revision. The thing is that the prior board, I mean, I didn't have it, I couldn't see it, but from what I saw, there was an array of I think diodes on the bottom, from what I could tell. I'm not so sure, maybe somebody can check this. And then there is the array of components that's not here. It's completely blank here, there's nothing, but it's on the board here. It's on this board. So it's a pretty different, pretty different. Okay, I don't know if maybe this is a same revision. I mean, same manufacturer, different revision, or maybe they're just completely two different manufacturers. I don't know. Unfortunately, when you destroy the MCU, there's not much you can do, and I don't think you can find the code for this. I mean, as I said, probably if I have some spare time, I will try to make an Arduino version with a nano or even mini and reuse this board as a contacts. That's all. This screen here, it appears to be driven in SPI because it has 8 pins. 2 of course are plus and minus, and there are 6. It could be like this, maybe you see this little there's a little transistor here. I don't know if this is used for the lighting control. I will have to check. Maybe this can be reused, but I don't know. That's just speculation. So I guess that was it. So be careful.